Okay, question 7. So we've got a triangle and we're told that DE is 8, EF is 12, and sine of the angle E is 2/3. Calculate the area. Well, the first thing I'm going to do is just mark this up and say that sine of E is equal to 2/3. I quite like doing that because graphically it shows me that I know this length, I know this length, and I know this angle. So I don't need to worry this. I like it in diagram form, okay? So when we see this, it should be jogging memories. The equation of a triangle for the area, you could say a half base times height, but in this case we can't do that. Okay? When you think of triangles, if you've got an angle in there, it's not going to be the half base times height equation. It's going to be area is equal to AB, sorry, a half AB. So messy, so messy. Area is equal to half AB sine C. Okay. Now that is in the front of the paper, so it's written down for you. You don't have to remember that at all. The only thing you have to know is that it's there. So when you see area triangle, think, well, I've got the equation. Can I do anything with this? And here we've got two lengths, okay, and an angle. And what do we need? Two lengths and an angle. So that's very genius to work out. All right, well, looks like I can just sub that straight in. Now, just while we're talking about this, the only thing you maybe need to know about that equation is what is A, B, and C. Okay. Now, if we were drawing a triangle, we would call our sides A, B, and C. Doesn't matter which A, B, and C. Okay. But the point is, the opposite angle from a side has to have the same letter, but we would give it a capital. Okay. So across from side A, we would have angle A. Across from side B, angle B. Okay. That's the only thing that's important here. Okay. So as you can see, we've got A, we've got B, and we've got angle C. So the point is, we're going to use an angle that's between two sides that we know. Okay, so they could have dressed this question up and said, well, what if this DF was 13? Okay, now calculate the area. And you'd have to know only to use the 8 and the 12. Okay, so just remember that when you're doing the equation, you're looking for two lengths with an angle in the middle. Okay, so it doesn't matter what we call A and B, as long as they're either side of the angle. Okay, so that's the only tricky bit, kind of understanding what we're doing. But even if you didn't understand what we're doing, you would have got the right answer because we've only got three inputs. Okay, so we've got half times A, I'm going to call A 8, B is 12, and sine C is 2/3. So I don't have to worry about doing inverse sine or anything. I know what the sine is, okay? Or sorry, doing what sine is. Now again, I could just work this out. Half of 8 is 4, 4 times 12 is 48, times by 2, 96, divided by 3 is 32. Okay, so I could just do that. But what if it was slightly more complicated numbers? Okay, I'm not great at, my 13 times table and stuff like that, okay? Well, we need to simplify to make life easier. So there's a 2 on the bottom and a 2 on the top. Let's get rid of them. So they would just become 1. There's a 3 and a 12 here and here. So let's divide these by 3. So that becomes 1. That becomes 4. And now the equation simplifies to, well, this is just 1. So we've got 1 times 8 times, which cancel that, times 4. Because 2's cancelled out, 3's become 1, yeah? So we just get 8 times 4 left. 8, 16, 24, 32. And don't forget your units, centimetres squared. Okay, so obviously we can do this equation, right? That's not that hard to just do the numbers, but just to practice breaking it down. All right. Marking scheme. What does the marking scheme say? A mark, it's not a lot really going. There's a mark for subbing in your equation and a mark for doing it. Okay, so not a lot of work there. Okay, question 8. So we're about halfway now. I think it's 15 questions in this paper, about halfway. So I can't just quickly go through them. I thought there's been a lot so far. Area of a triangle's not been too bad. Straight line. Like I said, I don't even think this qualifies as maths. This is just like battleships. Okay, breaking out the brackets, very straightforward. Our fractions, there's only a few rules for the fractions. Smiling cross, flick change, KFC, keep flick change, okay. The statistics question, again, I went through all of almost everything you could be asked. I agree there's not a huge amount in that, and then substituting in. Okay, so right up to now, we should be saying, well, actually, I've not had to think a huge amount. Quite straightforward, yeah. So we should be feeling quite good, quite confident. That's what they do. They try and build you up, and then the questions are a wee bit harder. Okay. So solve algebraically the inequality below. Algebraically just means with maths, so we don't even need to say that. Okay, I'm not going to sit and guess what x is. I'm not going to substitute in 1, 2, 3, 4, 5. Okay. So 19 plus x is greater than 15 plus 3x minus 2. Now the very first thing I'm going to do is break out this bracket. Okay, so 19 plus x stays the same. And you know what I'm going to do? I'm actually just going to write this as x plus 19 so I think it looks neater. Okay, and so x plus 19 is greater than 15 plus 3 times x, and 3 times minus 2 is minus 6. And now I'm going to group the terms on the right hand side. So 3x just stays the same, 15 minus 6 plus 9. Okay. And now I'll put my x's to the left and numbers to the right. You could do it either way, but that's just how I like to go. I like x on the left. Okay. So I need to take away 3x, don't I? Okay. Now again, different ways of thinking about this, and each time I do it, I kind of try and explain several different ways. The way I like to think on it is I'm balancing out this equation. So if I've got 3x here and I want to get rid of it, I need to take away 3x, yeah? So 3x take away 3x would give me 0, okay? But I need to do this to the other side as well. So what I do to this side, yeah, I have to do to this side. So that's why when we talk about changing the sign, that's why it appears on the other side a different sign, okay? Because we do 3x minus 3x here, we also do minus 3x over there, okay? So that's one way of looking at it. So if I group the terms, x minus 3x, that's minus 2x, plus 19 is greater than 9. Move 19 over, and again, the other method some people do is they have the working line. So they say, well, plus 19, what's the opposite of plus 19? Take away 19. So if I take away 19, I'm going to get minus 2x is greater than plus 9 take away 19, which is minus 10. So some people like the working line method, where they just kind of write down all the little opposite operations and then carry them out. Okay. I quite like this balance method to be fair, but the working line is quite common. Okay, but the point is, as long as you know to move, if 2x is equal to 5, if we want to move something from one side of the equation to the other, we do the opposite. So this is 2 times. So to undo that, we do divide by 2. So that becomes x is equal to 5 divided by 2. Okay, and again, as you start doing them, it starts to become easier and easier. I just think of 2 as being upstairs, and to move it over to this side, it goes downstairs. I don't even I can visually just think about how it moves. So yeah, this is a good time to just check that you can manipulate formulae. Okay. Minus 2x is greater than minus n. I want the x on its own. So how am I going to get x on its own? Well, I'm going to have to divide by minus 2. Okay, so divide by minus 2. Now, this is the only thing. Actually, what I've done here isn't quite right, because if we divide, yes, I'm just not going to put that. That technically didn't make sense. Yeah, so if I write this, okay, this actually no longer makes sense because this sign needs to change. When you divide by a negative, the sign changes. Okay, so if I just go back, this is correct, but then the next line should really say minus 2x divide by minus 2. Yeah. So actually, at this point, you want to show the sign changing. Okay. So obviously, this just becomes x, and this becomes 5. Okay. So if x is less than 5, then 5 has got to be greater than x. Okay. So these are the two options you could have. It's fine just to leave it like this. But that's the only rule you need to know. Okay. So I'm just going to highlight that. That's the most important thing. Okay. So if we've got we divide by negative, we change the sign. That's the only rule for the inequalities. Okay, because basically, apart from that, the inequality is an equal sign. Okay, so this is the only rule you need to remember here when you do that. So it doesn't matter if you're taking away negative numbers. It doesn't matter if you're multiplying. It's only when you're dividing by the negative part of the negative number that it's going to change sign. Okay, and again, let's just check we've done that correctly. Okay, so once you get your answer, just think, okay, does that make sense? X has to be less than 5. Okay, so if I put 5 into this equation, 19 plus 5, 24. 24 is greater than, let's see, 5 minus 2 is 3, times 3 is 9, 15 plus 9 is 24. So that's actually when they're equal. Okay, so that makes sense then. Okay, so they actually equal each other when it's 5. So what about when x is less than 5? If we say it's 4, okay, so 19 plus 4 is going to give us 23. 4 minus 2 is 2, times 3 is 6, that's 21. Oh, there we go, that makes sense. Okay, so when we said x is 5, they balanced exactly. When we said x, when we put x is less than 5, it works. Let's just try when x is greater than 5. So we put in, say, 6. Okay, 19 plus 6, that's going to give me 25. 6 minus 2 is 4, times 3 is 12. 15 and 12 is 27. Okay, so that doesn't work. Okay, so that's when we know we've done it right. Okay, so we've just proven that what we've done is okay. So again, if you just check that, then you think, well, if that's not working, you've made a mistake somewhere, and you just go back and think, well, where could the mistake be? And it's usually at this change in the sign point. Okay, nice. So there's an easy way to check if you've got it right or got it wrong. Okay. Right, so you were getting a mark for expanding the bracket. So just writing this and expanding the bracket, 1 mark. Okay, everyone can do that. So don't just look at these and abandon it. That is very straightforward. Collecting the like terms. Okay, so once we get to the stage of here, there's another mark. Okay, and then you're getting your final answer. So you're getting 2 out of 3, you're getting 66%. Okay, for multiplying a bracket out and collecting terms. That's first year work. Okay, this up to here is just first year. So, again, there's loads of hope when you go through these. Even if you're not great at finishing off the questions, you make silly mistakes, you struggle, you can still pick up some good marks all the way through the paper by just writing the question down, having a think, and just working through for a couple of minutes, see what you get. And once you get your answer, check to see you got on. Okay, good stuff.